A pleasant and productive morning for everyone. We are the Group 8 and today we are going to be tackling the topics given to us. And first, before we start, I am Andre Diego, and for today's topic, we are going to be discussing about first the conditional and related statements, which the following objectives that should be followed, which is first to understand the concept of conditional, biconditional, and related statement. Second is to practice them and to learn them in various contexts. And lastly, to understand the practicality of them in real life situations. The theme for this is differentiating conditional, biconditional, and related statements through various contexts of solvings. What really are conditional and biconditional statements? A conditional statement represents the relation of two statements with if-then format, while the biconditional statement uses the if-only-if format. But we'll be delving into this topic more.
Good day everyone, I'm Ishanis. I'm from Group 8. In this video, I'm going to talk all about conditional statement. So what is conditional statement? A conditional statement describes the relationship between two events based on a certain conditions. It is also known as if-then statement because it states a specific situation and then explain what can happen when that condition is fulfilled. This form is used to talk something that is probable future result of a condition.
Biconditional statement is a logical conditional statement in which the antecedent and consequent are interchangeable. It combines the hypothesis or the antecedent and the conclusion, which is the consequent, in which the statements can only be true if both elements are true only when they meet their exact requirements. Biconditional statements are written as P if and only if Q. For example, the hypothesis is a number divisible by 2. Then the conclusion is an even number. The equivalence is only true only when both P and Q are true or both P and Q are false.
Related statement. So there are three kinds of related statement: the converse, inverse, and contrapositive. So what is converse? The converse of a conditional statement is formed by switching the hypothesis and conclusion. For example, if you have the conditional statement, if it is raining, then the ground is wet. So the converse would be, if the ground is wet, then it is raining. So next, inverse. The inverse of a conditional statement is formed by negating both the hypothesis and conclusion. For example, if you have a conditional statement, if it is raining, then the ground is wet. So the inverse would be, if it is not raining, then the ground is not wet. So the last one is the contrapositive. So the contrapositive of a conditional statement is a form by negating both the conclusion and the hypothesis and then switching their order. For example, if you have the conditional statement, if it is raining, then the ground is wet. So the contrapositive would be, if the ground is not wet, then it is not raining.
Good morning everyone, I am Lovely Tinagan, and now we'll be tackling about the lesson 2, which is symbolic arguments. Our objectives is first, to understand the symbolic representation of valid arguments. Second, to explore the symbolic nature of invalid arguments. Then lastly, to analyze the implications of valid and invalid arguments in symbolic logic. With the title, The Nature of Valid and Invalid Arguments, a Symbolic Analysis, and the theme, Exploring the Symbolic Nature of Valid and Invalid Arguments. What is symbolic arguments? Symbolic arguments are arguments that are written in symbolic form using letters and other symbols to represent the connectives like F, then, or, and end. A symbolic argument consists of a set of premises and a conclusion, and it is called a symbolic argument because it is generally written in symbolic form to determine its validity. There are two types of symbolic arguments: the valid and invalid arguments. So what is valid arguments? In logic, an argument is valid if it only takes a form that makes it impossible for the premises to be true and the conclusion to be false. A valid argument is one where the conclusion necessarily follows from the premises, meaning that if the premises are true, then the conclusion must also be true. Law of detachment. This law states that if a conditional statement and its hypothesis are true, then the conclusion is also true. As we can see in the picture, if Groundhog Phil sees his shadow, then there will be 6 more weeks of winter. So Groundhog Phil saw his shadow. Therefore, there will be more 6 weeks of winter. This is valid argument since the conclusion necessarily follows from the premises. Law of contraposition. This law states that if a conditional statement is true, then the contrapositive is also true. In the picture, if you kiss the frog, then it will turn into prince. The frog did not turn into a prince, therefore, you did not kiss the frog. This is valid argument since conclusion necessarily follow from the premises. Law of syllogism. This law states that if a conditional statement and another conditional statement are true, then the conclusion is also true. In the picture, if you give them an inch, then they will take a foot. If they will take a foot, then they will take a mile. Therefore, if you give them an inch, then they will make a mile. This is valid argument since the conclusion necessarily follows from the premises. Disjunctive syllogism. This form of syllogism involves two premises, one in the form of either P or Q and another in the form of not P and not Q. The conclusion is either not P or not Q. In the picture, dogs roll or cats drool. Dogs do not roll. Therefore, cats drool. This is valid argument since the conclusion necessarily follows from the premises.
So my name is Talinting Jeracate, and then the next one is an invalid argument. So what is invalid argument? In logic and reasoning refers to a line of reasoning where the conclusion does not logically follow from the premises. Even if the premises are true, the conclusion may not be a necessary consequence of those premises. In other words, the argument structure is flawed, making unreliable for proving the truth of the conclusion. For example, premises 1, all mammals have wings. And then the next one is premises 2, dogs are mammals. So in conclusion, therefore, dogs can fly. So this is an invalid argument because the conclusion does not logically follow from the premises, even though the premises themselves might be true. Invalid arguments are distinct from unsound arguments which have both an invalid structure and at least one false premises. So the next one is the fallacy of converse. So it occurs when someone mistaken assumes that the converse of a true statement is also true. In other words, if a statement is a form of if A then B, then the false fallacy of the converse involves incorrectly asserting that if B, then A. So here are the examples of the fallacy of the converse. So this is the statement. So if you build it, they will come, they come. Therefore, you built it. So this is an invalid argument since the conclusion does not necessarily follows from the premises. So the second one is the fallacy of the inverse. So it is a type of logical fallacy where an incorrectly assumes that the negation of the conditional statement is equivalent to the negation of its converse. So in other words, if a statement is of form of A and B, the fallacy of the inverse involves incorrectly asserting that if not B, then not A. So this is the example of fallacy of inverse. So this is the statement. So if I think, then I am. I think not. Therefore, I am not. So this is an invalid argument since the conclusion does not necessarily follows from the premises.